model like, yeah, they're valid numbers. They don't give you the same answer. These are more human characteristics. But they aren't exactly human either. And Simon Wilson put it quite well. He said one way to think about this is imagine that aliens came to us and gave us a copy of their intelligence a few years ago. And since then, we've been poking around trying to find out how these things work. They make mistakes, and they make mistakes that are very different from computers. They make mistakes that are very different from humans, and we are learning a bit about their behavior. One of the things that we see is that they have biases, and these biases are not very different from the kinds of biases humans exhibit, obviously, because they've been trained on human data. So, for instance, if you ask them to guess a random number, take the exact number, pick a random number from 0 to 100, and write only the number, nothing else, then the kind of output that you get looks like this. Every time you try it, it guesses a number. You keep counting the numbers. And a few numbers bubble up a lot more than others. Yeah. And you know which numbers are bubbling up the most. And you know why it's bubbling up the most. Clearly, the people that trained, this is Claude 3 IQ. And yeah, it loves Douglas Adams. And for those who may not be aware, just check out Douglas Adams in the number form. But there are several other biases that you'll find. There are no single-digit numbers. There are no numbers in the 90s. You won't find any guess of a number that ends with 0. So no 10, 20, 30, 40. You'll almost never find a number with repeated digits, 11, 22, 33. These are the kinds of numbers humans avoid as well when guessing. And this is not the only model that does it. If we look at how GPT 3.5 Turbo guesses, 37, 47, 57, 72, 73, 74, 87, no difference for sevens. Now, this is a preference that varies based on temperature as well. Let me read on this, except the graph on top shows the guesses that it's making at different temperature parameters. You can tell a model, I want you to guess a little more randomly or less randomly. More randomly is higher temperature, less randomly is lower temperature. And when it guesses with very low randomness, or put another way, if you say, think of the first number that comes to your mind and tell me what that random number is. Then in the case of Claude 3 IQ, that number is almost always 40. With barely any exceptions. Let me just jump straight to the end on this one, stopping the animation. And pause it, I should pause it. And right. So with close to 90, about 98% of the time, it guesses 42, and small chance, about 1.5% of the time, that it comes up with 47. But if you increase the temperature to as high as 1, which means guess a lot more randomly, it still guesses 42 a lot more, about 21% of the time, but it guesses 47 about 15% of the time, and so on. So there's a wider distribution if you nudge it towards more randomness, but only slightly wider. It's still very human in its biases. Classic biases that you can see: multiples of 2, slightly less common; multiples of 5, a lot less common; multiples of 10, almost never there; and multiples of 11, very unlikely. So if they're going to exhibit these kinds of biases even when we tell them to guess random numbers, how much can we trust them to be objective? Not very, perhaps. Having said that, the quality of these models is improving. They are getting much better at following instructions. And one of the ways in which we measure model quality is through an ego score. The LLMs leaderboard is generally considered the most, well, it's certainly one of the most popular ways of checking the quality of a model. What that allows us to do, once it loads, is it will give us two models, model A and model B, without telling us which model it is. And we could ask it a simple question. When was that of Hastings. A simple objective question that no model is likely to get wrong these days. But on the left, we have an answer that's somewhat detailed, telling me about the Battle of Hastings, another that just gives me the answer. Quick show of hands, how many people prefer model A on the left? Okay, let's go 5, 6, 7. How many people prefer model B on the right side? Okay, clear majority. So this group likes B, and then it tells us that B is Gemini 2.2/001, a very new model, whereas this is cohort Chowder, who knows, it might be an even more secret model, we don't really know what this is. And this vote goes into the mix along with about 3 million other votes, and based on that, they've computed a ranking almost exactly like how chess players compute their ELO score. So somebody at say 2,400, 2,500, it's grandmaster level. Somebody at around 900 is a beginner player. And we have models today that are at the 1,400, 1,300 level in terms of ELO score, which means they're pretty good. My mental notion of these is that today we have roughly postgraduate level intelligence in these models, whereas about a year ago it was more like high school level intelligence. And this has steadily been improving over time. So if we start plotting from, let's say, March 23, the quality, that is the ELO score, on the y-axis, and the cost per million tokens on the x-axis. So a million tokens is approximately all the Harry Potters put together, or King James Version. You take all of that and send it. How much time, how much money does it cost to process it? $1, $10, 1 cent. So that in March 2023 there weren't that many models. Claude 1, Instant, GPT 3.5 Turbo, there were a few more. But these were the ones that provided APIs with a known cost and benchmark quality. But that improved over time. And what you see is that about a year ago, in March 24, we had a frontier of sorts. Some models, like Claude 3 IQ, had emerged which were clearly ahead of the rest in terms of the trade-off. It kind of stands out a bit on the top left, meaning they are cheaper for the kind of quality that they have compared to most similar ones. The ones in green are what I call the frontier models, in the sense that there's no model that's both better and cheaper than them. Some models, like let's take Gemini Pro Dev API at that time, there was no reason why you would use that model by and large. Because Claude 3 IQ was cheaper and better. So why bother? This frontier has been steadily improving. So another big burst was when Gemini 4 Mini came and pushed the needle. DeepSeek V3 pushed the needle a fair bit, and DeepSeek R1 pushed it even more. Of course, on the right side, we have the quality steadily improving. Currently, GPT, as of last week, I don't know if it's changed. But GPT 4.5 review is pretty close to the top. Grok 3 is comparable or perhaps even higher than that. So the quality has been improving to the point where these hallucinations are becoming less and less of an issue. A fair bit of what you see today may become irrelevant soon, or not, because there are various reasons for hallucination. But even if hallucinations were present and were reducing, hallucinations are not always bad. There are several good things that have come out of hallucinations, several innovations. I'm sure you've heard the story of how penicillin was actually a mistake. Post-it notes, pacemakers, microwave ovens, psychedelic rock, the script of the Matrix. And these came out of, some cases literally, hallucinations. So from a creativity perspective, from a serendipity perspective, from a discovery, randomness perspective, hallucinations can be good things, as long as we know what we want and we're choosing it consciously. So do keep in mind that we don't always want to eliminate hallucinations. We just want to make sure that we know we're hallucinating consciously. So if we do want to minimize hallucinations, what do we do? I use three approaches progressively. The first is using log props, the second is using embeddings, and the third is using another LLM as a judge. Let's walk through each of these. When an LLM generates the next word, it guesses what that word might be. The technical term is token, but I'm going to say words. And the way it does it is kind of like a dog laying a track for the train that it's riding on. So it guesses the next word, guesses the next word, and keeps guessing as it goes along. Not very different from how we think and speak. We just start speaking and think about what the next word should be. Say we, but I really should say I. And we're just making it up as we go along based on our experience. LLMs are not very different. The good thing is we can inspect LLMs a little more closely. For example, OpenAI provides us an API, and as part of that API, we have the option of enabling a parameter called log props. When we enable that, so if we say log props true and give me the top 5 log props, it will at every word tell us what the top 5 choices that it's thinking about, and give us the probabilities of each one of those. Often it picks the highest probability result, but not always. Sometimes you can ask it to pick something with a slightly lower probability. Why might we want it to do that? For variety, for creativity. The top choice may not always be the right thing. Let's see this in action. What I'm going to do is take you to a simple interface, an app, where I'm going to ask it to concisely list 5 inventions created by human error or hallucinations. This is in fact a prompt that I used to create the earlier list that had penicillin and post-it notes and stuff like that. I'm going to ask this of GPT-4o mini, but we are not limited to the OpenAI models. Several models provide the log props. Olama, which some of you have tried earlier, provides an interface where you can get the log props as well in many cases. And there's a temperature setting. A temperature setting of 0 says always pick, pretty much always pick the first choice or the highest probability. If I submit that, then it's guessing, and we also highlighted in red the probability. So, for instance, let's take penicillin. When it started guessing, it thought maybe I'll say pen something. That was a 57% chance. But it said maybe I should start with mic, going towards microwave ovens perhaps, 27% chance. Post, so that was probably going towards post-it notes, 9% chance. Well, that's probably Velcro. I don't know what the last week was going towards. We still have these Velcro. But it was thinking about what should I say, and in its mind, these were the first 5 things that popped up, and it picked the first. And it's always picking the first. But after it said pen, it had no doubt that it should continue with penicillin or is. There's a tiny chance that it could have said is side, penicillin. What is that? Nah, yeah. Probably seen that in a few typos, but I really shouldn't see that. So it didn't have any doubt here. It didn't have much doubt when it wanted to begin with discover. But it wasn't entirely sure if it should use the word realized or noticed or found. That's kind of helpful because I know where it's unsure and can double down on that. In fact, if I increase the temperature, so let's set it to something like 1.5 and submit, 2 things happen. At this point, it's no longer picking its top choice. It's picking stuff from way below. And you'll see that many of these are a lot less likely. So for instance, penicillin, discovering antibiotics started. So it thought it should begin with this, and it did go with that. It instead said discovering, which is not such a big deal. That accidental, it wasn't really sure if it was accidental or not. So that's something that I may want to double click on and see if it is in fact reliable information or not. Realizing, okay, leading, realizing, was that actually a realization? Let's try one more attempt at this to see if I can get some crazy hallucinations at temperature of 1.5. maybe that's okay. Okay, super glue. Now, it isn't really sure if it should have begun with Harry Hoover or chemical engineer. So, was Harry Hoover actually a chemical engineer or not? Something worth checking. This is one quick and dirty way of exploring whether LLMs are confident of their result or not. There is a metric called SEQ, sequence log props, which is roughly taking the average of these log props. And that tells you to what extent the LLM is sure of what it said, crudely speaking. It does not translate to meaningful information always. The fact that it said something with less confidence does not mean that it's wrong. But it's a place to start looking. There's another way in which we can use LLMs for hallucination detection. LLMs are also great at creating embeddings. Embeddings are a way of quantifying a piece of text. Given text, it can convert them into a vector of numbers. With the interesting characteristic that if two vectors are very close to each other, they mean something very similar. If they're far away, they mean something less similar. Now, one of the places where we want to detect hallucinations is I ask a question, is it giving me a relevant response? And if the response has very little similarity to the question, that's probably an indication that it's off. Or I could generate some sample answers, and if the response is again very far away from my sample answers, something's probably off. How do embeddings work? Well, embeddings are not new to LLMs, by the way. Several models have them. TensorFlow, for instance, provides a TensorFlow projector where I can search for something like Thailand and explore this multidimensional space to see what are vectors that are close to Thailand. And I find that, let's say, Laos is close by, and close to Laos is Cambodia. And these have a similarity metric here that tells you numerically how close two pieces of text are. And that's helpful. Let's see how we can put that to use. What I'm going to do is take a bunch of documents that have been scraped from Insider Intelligence's knowledge base. They're a marketing research company, and they have about 7,000 articles, which are mostly useful for marketing managers. And I'm going to ask a question. Let's say, what LLMs do marketers use? Actually, let me ask one of the standard questions that it has. What is Amazon's business model? And it searches through its database, through its database, right? And it finds a bunch of responses. What we can do is calculate the embedding similarity between our question and the answer. And that's what we see here as a percentage. So this article is 93% similar to our question. This article is 87% similar to our question. Similarity does not directly translate to relevance. If I ask the question, what's good about Amazon versus what's bad about Amazon, the questions are very similar to each other, but they mean almost the exact opposite of each other. So again, treat this with a pinch of salt. It's not perfect. But given these numbers, what we can do is take each of those documents and color code them. Bright green meaning high similarity, light green meaning less similarity, and you can go all the way down to red. But also something interesting happens because you can start interconnecting those documents as well to each other. So are there clusters of documents that are talking about Amazon's business model? Are there outliers in this? Let's say I'm talking about Netflix's financial performance. Again, are there topics that are somewhat distinct? So it looks like there are a few clear clusters. Here's one cluster that's talking about a set of relevant topics on Netflix's business model. Here's a completely different cluster. What's this about? We could dive into those, read those, or have an LLM summarize. And this cluster seems to be specifically about Netflix's ad supported tier, which is different from this main cluster, which is talking about something else. This cluster is talking about what's the common theme across these. But this allows us to also identify outliers, not just the. So here are a few unusual topics related to Netflix's financial performance. But how does this help detect relevance or hallucinations? Now, supposing I wanted to know, let's take that question. What LLMs do marketers use? I find that it's not as green as before, meaning the relevance is not so high. So without even reading the answers, I start trusting the responses a little less. Say, okay, yeah, maybe this one comes close, but we don't really have enough information in this database. And that's another quick signal that helps us figure out if these hallucinations, if these responses are trustworthy or not, and need a double check. The third thing that we can do is use LLMs as a judge. Now, LLMs are not always wrong. In fact, more often than not, they are correct. That goes for humans as well. So the way we check the human's response or output through potentially other humans or any other mechanisms, we can use LLMs to check other LLMs' responses. And that's the theme behind LLMs as a judge. And this works a little better because the mechanism is a little smarter. Let's take an example. One of the things we can do is, supposing we have a bunch of contracts. Let's say, take some contract like this. Reload. This is, for example, the contract between an author and a publisher that has a whole bunch of clauses. Now, this contract was generated by an LLM. What we want to do is check if this contract is following all of the principles that we gave the contract, that we gave the LLM at first, which is there must be a breach of contract term, there must be deadlines and delay consequences, there must be copyright omissions covered, and so on. Analyze it, and what it does is goes through each one of those and says, yeah, breach of contract, I found that in section 14.2. Section 2.5 has deadlines, delay consequences, and so on. But it did not have anything about disparaging statements, reputational risks, and stuff like that. So this is helpful. And you can do that in bulk and say, take every single contract, take every single term, what did we get right, what did we not get right, and yeah, put that into a nice little picture that says, okay, this particular contract, this particular clause is present in all the contracts marked green, it's not present in all the contracts marked red. Or this particular contract has all the stuff that's marked in green, not all the stuff that's marked in red. Useful to get a quick picture of where we are overall. In summary, there are 3 ways that I, in sequence, check for hallucinations. Quick check, log logs, that's free, and low confidence. Embedding similarity, very low cost, but slightly better quality, not perfect. And LLMs as a judge are the most expensive, but perhaps the most reliable. Do keep in mind that LLMs are evolving so fast that a year from now, many of these techniques are likely to be outdated. We would have discovered many new things. But it's worth playing around to get a sense of how LLMs go wrong and what we can do with it as well. Slides are on that link. Please feel free to play around. The demos are open source. You'll be able to see the source code for these. Have fun. Thank you.
Thank you. These are some cool tools, such as LLMs judge. I'm curious, do you have a formal definition of hallucination that you use? Because I think yours is a little bit wider than one that I typically use.
I have no idea what the formal definition is, so I'm curious.
Okay. All right, well, so basically for AIs, there are 3 categories of errors. Category 1 errors are errors where an LLM will state something as factual that's clearly wrong. That is my definition of a hallucination. Category 2 error is, and your LLM judge maybe addresses that, is when you have content that it should have found, but it did not. So you're missing content that you wish it would have found, especially relevant to RAG systems. And then category 3 errors is the example that you gave at the very beginning, overgeneration, right? It's not wrong, but it's also not necessarily relevant to the thing. I was kind of inferring from what you're describing is basically, go back to Douglas Adams, right? The infinite improbability, right? Is that you? I inferred, I may be wrong, that hallucinations are just improbable results.
And that's the good point. That was my starting point on hallucinations. And if we define hallucinations as, how you said, it's factually wrong, there is going to be a correlation, not a overlap between just improbable results versus factually correct results. That one. Thanks, Anand.
Thank you. And that's all the time we have for. Thank you.